How did 19 go? Kind of tricky.
Question number 2 is
Terrible.
my favorite.
Number 2 is your least favorite?
Okay, question number 1.
Exciting.
Question number 7 is really challenging.
All right. You did 45 today, right?
Number 7 is hard.
All right, so let's get into it. Number 1, it just wanted us to expand or distribute to write an equivalent expression. So we distributed the negative 1/4 to each term here. And what was our equivalent expression, Georgia?
2x plus 3y.
All right, I like 2x and I like 3y. But what should be a little bit different there, Josh?
Negative.
It should be plus a negative 3y, right? Because this is a negative 1/4 we're distributing. Everybody okay with that? All right, then the next one we're going to factor. So we had to figure out what we could pull out from 36a minus 16. What do we pull out, Chesney?
4.
4. And if you did that,
I had 9a minus 4.
9a minus 4. That looks good. Did everybody do anything different? Anybody pull out a 2 at first and then realize another 2 could have came out? No? We all just went right to 4? All right. Works for me. 2, Jared's least favorite problem. It says Lynn missed math class on the day they worked on expanding and factoring. Kieran is helping Lynn catch up. And A wanted us to explain how we could factor, or explain what factoring is. So who wants to share what they had for an answer? Kellen?
Find what numbers would go into the numbers that you have to find the original equation.
So find a common factor and then pull that out? That would work? Anybody say anything different, or do we all have something kind of along that? Jared?
I said factoring is finding a number that can be divisible by all of the numbers expanded. You put that number in the front and put parentheses, divide all numbers, and boom.
That sounds good to me.
That's one.
I heard
Yep.
that myself.
Mine is like 6 words.
What are your 6 words then?
I don't know. Actually, no. There's
All right.
3, Josh.
So I like what both of those we heard so far. But we could have just said factoring is distributing in the other direction.
That's what I put.
There you go.
Yeah.
I said you are doing the opposite
Alright.
of expanding.
That's exactly what it is.
What's that?
Distributing,
Well, then again, she didn't know what expanding
we're
was.
multiplying numbers in, right?
How do you know?
So any number out front of the parentheses, we multiply in by the terms in the parentheses, and then factoring, we're just pulling out. So those are the opposites there. Expanding and factoring are opposites. B says, Lynn asked Kieran how the diagrams with boxes help with factoring. What should Kieran tell Lynn about the boxes? And remember, we're not talking about our diagrams. We're talking about these boxes on page 141 here that helped us expand and factor. Jonas, what'd you say for B?
I put that if you have the numbers on the outside of the box, you multiply them together to get on the inside. If you have like on one side and the inside, you divide those to get the one on the other side.
All right, that sounds good to me. We multiply the numbers outside the box to get the number inside the box. All right, and then factoring would just be the other way. If we're missing a number outside, we would just divide. All right, the last one, C, it says Lynn asked Kieran to help her factor the expression negative 4xy minus 12xz plus 20xw. How can Kieran use this example to help Lynn understand? Autumn?
I said since 4 like goes into all these numbers, you put like that outside the parentheses, then you divide 4 from another number, and like add the the quotients that you get from dividing them to the equation in the parentheses.
Okay,
And then yeah.
that sounds good to me, but what else can we pull out of this, Jared?
I just said, how can Ron use this example to understand factoring? I said by solving it with her, by going through step by step.
Yep. That would work. We could solve this one. But what else? So we took a 4 out already. That looks good to me. Jessa, what else could we pull out of that? An x. They all have an x, right? So we could pull out 4x here. Now it'll leave us with negative y minus 3z plus 5w in our parentheses. And then if we, just to explain, we could just say they all had a common factor of 4x. So we can pull that out from each term. So we can just say common factor of 4x gets pulled out. All right, we all okay explaining that to somebody else? We comfortable with that? All right. So then 3 said complete the equation with numbers that make the expression on the right side of the equal sign equivalent to the expression on the left. So in this one here, our left side is 75a plus 25b. Before we look in the parentheses, what number can we pull out of both of these? Brooklyn?
25.
We could pull out a 25, so that's what will come outside the parentheses. Now what number has to be with a here to make this true, Kaylee? 3. Should be our numbers that go in the blanks there. All right. 4 was our paint problem, and we set it up. We said each batch is 5 cups of purple paint, and we had 2/3 of a cup of white paint, and we don't know how many batches we could make with that much white paint. So we set it up by taking 2/3 divided by 1/2. And what did we get if we did that, Colin? 4/3. So that was how many batches we made. But the question was how many cups? So then what was our next step? Sophie, what was our next step?
Taking 5 over 1 times 4/3.
Yep, we multiply 5 by 4/3, and that would give us 20/3. Sneaking off the screen. So that's how many cups of paint we can make, cups of purple paint. So that was our answer on number, or A there. B then wanted to know how much blue paint and how much red paint would Elena need to make this much purple paint. Kellen, what do you think?
For blue, I put 4 cups,
So 4 cups of blue
and then for red, I put 2.
and 2 cups of red. How do we feel about that?
I got 2.5 and 4.5.
All right, well, let's talk about how we got there. All right, Kellen, what do we do to figure out how many cups of blue?
Okay, well, to start with, I took the 2/3 off of the 6 2/3 because that was the white paint. So, and then I just figured out like which one. What did I?
All right. So what we could have done is we could have said how much blue paint did we use to make 5 cups of purple? We used 3, right? 3 cups of blue paint. So we could have taken 3 divided by 5 to figure out our ratio there of how much blue paint was in our original mixture. If we do that, we'll get 0.6. Then we could just take this 0.6 and multiply it by our 20/3 because 60% of that purple paint would be blue. Question?
What if you just took 4 over 3 times 3?
Because that's how many, 4/3 is how many batches, and you knew we were making 3 more batches?
No, because there's 3 cups of blue paint.
Okay, yep, that could work too. Yep, because 3 cups of blue paint in 1 batch. Yep, so that would work as well. But either way, we should get 4 cups there. Are we all okay with either of those methods to get there? All right, so 4 cups of blue and 2 cups of red would be good on that one. All right, 5 just asked us to solve each equation. So A, we were supposed to solve for D, and we got this far. We had 29 over 8 divided by -1/8. If we did that, Kellen, what would D equal? 29. We all agree with 29? That looks good to me. How about B? What did we get for M? Kinley, what did you get for M?
I got 36.
36. Corbin, did you get something different?
-44.
That's what I got too there. -44 for M. We'd subtract 5 from both sides first, and then we have -1/4 times M. So we do the opposite, which is either divide by -1/4, or we can multiply by the reciprocal there. And then once we do that to 11, we'll get -44. All right? C asked us to solve for B. What did we get for B? Chesney?
I got -8.8.
And I got something a little different than that. Colin, what'd you get?
0.2.
0.2 or 1/5 is what you should get on that one. Remember, here we'd add 45 because this is a -45. So we'd add 45 to both sides here. -43 plus 45 is 2. 2 divided by 10 would be 1/5 or 0.2. All right. D, we're solving for Y here. Brenna, what'd you get for Y? 0.75 looks good. First we divide by -8 on both sides. That'll give us 1/2. on the right side, and then we would add 1.25 to each side there to get 0.75. Question, or you got the next one, Kellen? All right, what'd you get for S?
0.
S should be 0, right? We divide by 3.2 on both sides, and then that would give us 10, and we subtract 10. 10 minus 10 is 0. The last one, 6, said select all the inequalities that will have the same solution as negative 4x plus 20. So if we're going to figure out the solution to this, what's my first step? Colin?
Change the less than to an equal than sign.
So we change our sign to equal then, and then we can just solve this. So we solve by dividing each side by negative 4. And x would equal negative 5 then. What's that negative 5 tell me? Chesney, what's that negative 5 tell me? It is equal to x. But remember when we were working with our number lines? What does this x tell me now? Tells me where our circle is going to go, right? If we're going to plot this inequality on a number line. So our circle is going to be at negative 5. And we can just go back. So we have a less than sign. Is my circle going to be open or closed? Open, because negative 5 is not included. Now how can we figure out, do you remember how we can figure out which way our arrow goes, Colin?
Put 0 in.
We plug 0 in. So negative 4 times 0, is that going to be less than 20? Yep, so our arrow includes 0, so it goes to the right. So now all our solutions are going to have to be greater than negative 5. So now which of these, if we plugged in a number greater than negative 5, would be true? So say we go through each one of these and we plug in negative 4. Is negative x or negative 4 going to be less than 5? It will, right? This will flip our sign, so this will just turn into 4. So 4 is less than 5, so that one's true. Is 4 times negative 4 greater than 20? No, so that one's not right. Is 4 times negative 4 less than negative 20? Is negative 16 going to be less than negative 20? No, so that one's not right. Is negative 4 less than negative 5? No, right? Be careful with those negative numbers. Is negative 4 greater than 5?
Yes.
Negative 4 is greater than 5? This one would be true. It's greater than negative 5, but it's not greater than 5. All right? We should have got B there. Is that what you're going to say, Chesney?
No.
This one should have been true too, right? Negative 16 is greater than negative 20? All right. You have a different question?
Yeah, on number 5,
All right, so on C, because this is a negative 45, we have to add 45 to both sides. So we'd add a positive 45. Because what's negative 45 plus 45? It'd be 0. Right? So negative 45 plus 45 would cancel that out because we're trying to get our variable alone. So even though this is a plus right here, we have to add to make this 0. Because if we subtract, then we'd be at negative 90. And that doesn't help us solve any further, right? Does that make more sense? All right, any other questions on the homework? All right, if there's nothing